Hello friends, so this is a Harvard series physics problem and this problem is called rising hoop. So problem says two beads of mass m are positioned at the top of a frictionless hoop of mass m and radius r which stands vertically on the ground. So we have two beads, a small mass m, and this is basically resting on a bead of mass m. And this a hoop of mass m, and this hoop is resting on the ground. The beads are given a tiny kicks that they slide down the hoop, one to the right and one to the left as shown in this figure. So they have been given a small kick, so they have been applied a small kick, so they will move in this direction, and basically these bead will move on this ring in this direction. So one bead is left, another bead is right, and the problem is symmetric. So this is a symmetric problem. Everything is symmetrical. So next part says, what is the smallest value of m by m for which the hoop will rise off the ground at some time during the motion? So it is asked, what should be the value of m by m? That is the smallest value of m by m, so that the hoop will lift, or hoop will basically rise up off the ground. So the first question is, why the hoop will rise? You see, what is happening here is, these beads are sliding down, so these beads are applying a force. So these beads will apply a normal reaction in this direction. And this normal reaction will have two components, one component in this direction, one component in this direction. So vertical component of normal reaction has a tendency to lift this hoop, and a time will come when the vertical component from this side and vertical component from this side, that is this one and this one add, and this will be equals to mg. So at that point of time, this hoop will basically leave the ground and it will rise. So let us see how we can do this problem. So let us say this is the vertical line we have, and this one is the horizontal, and then from here this angle is theta. So this angle, let's call this angle is theta. This angle is theta. Now let us say, what are the forces that is acting on? So let us say we are concentrating on mass m, that is bead. So one force that will act in the downward direction, this force is mg. Another force is normal reaction. So basically bead is trying to push this hoop in this direction. So normal reaction on hoop is in this direction, but the normal reaction on the bead from the Newton's third law will be in this direction. So this is the normal reaction on, so this is the normal reaction. So let's say, so this is the normal reaction on the bead in this direction. Now this angle is theta, so this angle is also theta, so we can write in this direction this force will be mg sine theta, and in this direction we will have mg cos theta. So this direction we will have mg cos theta. So now let us write equation of motion. So this bead is moving in a circle, so we can write n plus this direction force we have, this is mg cos theta. So n plus mg cos theta is equals to mass into acceleration. So let's say at this point velocity is v, mv square by r. So this is my first equation. From where I will get the second equation? So to get the second equation, I have to apply energy conservation. So in this case, what will be this length? That is this length. This length will be So this length, in this case, this length is r cos theta. You can verify yourself. This length is r cos theta. So this length will be r minus r cos theta. So this length will be r minus r cos theta. So now you can apply energy conservation. So this bead has lost some energy. How much energy it has lost? So it has lost mgh, and h is nothing but r minus r cos theta. So this has lost this much energy, and how much gain? So gain is the loss in potential energy is equals to gain in kinetic energy in this case, that is half mv square. So from here you can write v square is equals to 2gr 1 minus cos theta. So this is second equation. Now what are the unknown we have? We have normal reaction is unknown, v square is unknown, that is v is unknown, and theta. So what we can do is we can find normal reaction as a function of theta. We can eliminate v. So from 2 we can plug into 1. So we can write, so n plus mg cos theta, this is equals to mv square by r, and v square is nothing but 2gr 1 minus cos theta. So from here I can write n is equals to, so this becomes minus mg cos theta, and this plus 2mg 1 minus cos theta. So n is equals to 2mg minus 3mg cos theta, or we can also write, if I take mg, so 2 minus 3 cos theta. Now see, very important point, this normal reaction depends upon theta, mg 2 minus cos theta. So sometime this normal reaction is positive, that is, if 2 minus cos theta is greater than 0, normal reaction is positive. But if 2 minus cos theta is less than 0, in that case normal reaction is negative. So you see, so what is happening? Sometime bead is applying a force on the hoop that is trying to push the hoop. But in some cases the bead is trying to pull the hoop. So basically for these thetas, normal reaction is positive. This means this is applying, so bead is applying a force to lift the hoop. So let us try to figure out what is the total force that is acting on the hoop. So vertical force. Vertical force. What will be the vertical force in this case? Vertical force will be n cos theta. So you see, so we can show it here. So this is your forces. This force is acting on the bead, and this force is acting on the hoop. So vertical component is this one, and this angle is again, so if this angle is theta, then this angle is also theta. So vertical component is n cos theta. So basically n by, that is the vertical component, is n cos theta. So now we can calculate n cos theta. So vertical component of force is nothing but n cos theta, and there are two normal components, one from the left bead, another from the right bead. So the total force is 2n cos theta. And we have already calculated n, that is 2 mg. So this is n, mg 2 minus cos theta, and this cos theta. Now see, this normal reaction depends upon theta. So this normal force depends upon theta. Now when this normal force will be maximum, so let us say, so we are interested to find the maximum upward force. So maximum upward force. So let's call this as a F, that is the upward direction. So this is a function of theta. So if we differentiate with respect to theta, then that will give me the maximum force. So that is simply, so I have to differentiate this function, that is 2mg 2 minus cos theta times cos theta, and then equate it to 0. So if you do this, you will have minus 2 sin theta. So you will have minus 2 sin theta plus 3 2 cos theta sin theta. 2 cos theta sin theta is equals to 0. So from here I can say, if I take sin theta common, so I will have minus 2 plus 6 cos theta, so this is multiplied, is equals to 0. So this means cos theta is equals to 1 by 3. So when we have cos theta is 1 by 3, the normal force is maximum in the vertical direction. What will be the magnitude of that force? So F will be 2mg 2 cos 2 minus cos theta into cos theta. So let us plug the value of cos theta. Cos theta is 1 by 3. So 2 minus 1 by 3 times 1 by 3. So this becomes 2mg, and this is 6 minus 1. This is basically there is a mistake here. So this is 3. So there is a 2 minus 3 cos theta. So this will be, everywhere I have to plus 3 here. 2 minus 3 cos theta. So this is 2 minus 3 cos theta. And then, that's why we have a 3 here. So 2 and 3. So this is 3. So 2mg 2 minus 3 cos theta. And then here I will have 3 into 1 by 3. So 3 into 1 by 3. So everywhere I forgot 1 3. So we will have 6 minus 3, that is 2 minus 1 1, and into 1 by 3. So this will be 2mg by 3. So this is the total force that will act in the vertical direction. Now to lift the hoop, what should we have? We should have F should be greater than mg, that is the vertical force should be greater than mg. So we will have 2mg by 3, and this term should be greater than mg. So from here we can say this m by m should be greater than 3 by 2. So minimum ratio of m by m, minimum ratio of m by m is equals to 3 by 2. So at least a small mass should be 1.5 times larger than the bigger mass. Then only it will lift the hoop in the upward direction. So this problem basically tests your concepts about how you write equation of motion in circular motion, and how you write energy conservation, and how you equate forces to see the equilibrium. So 3 concepts has been covered in this problem. So I hope you like this video, and if you like, please share and subscribe, and I will see you in the next video. Thank you so much.